Okay. Well, welcome everyone. Thank you for joining us today on your lunch hour. Just give you a little bit of background about myself and MaKenzie. My name is Luke Wenz. I'm a Director of Integration Services at Zirous. I've been at Zirous for over 15 years and played a lot of different roles over my time. Started in mostly development and then kind of worked through security, integration, cloud solutions, and have done a lot of that stuff. And I'm just really passionate about establishing best practices for clients with source control management, code quality testing, and just developing robust, scalable solutions.
And I am MaKenzie Clemons. I'm a Director of Research and Technology at Zirous. I have a background in development, data analytics, data architecture, and data integration, and I am just next week celebrating my 10-year anniversary with Zirous.
So just going to give you a brief agenda for what we're going to cover today. First, I'm going to give a high-level overview of DevOps in general. We'll keep that at a pretty high level. And then we're going to start focusing more in on Azure DevOps stack, and then getting more into Database DevOps. And then we'll close it out with the demo showing some of these tools in action. So at a really high level, what is DevOps? So a really wordy definition is DevOps is a combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications, services at high velocity, evolving and improving products at a faster pace than organizations using traditional software development and infrastructure management processes. So if we kind of just boil that down, it really just means we're getting the integration, development, and operational teams to deliver solutions faster and more reliably. So if we take a look at a historical approach to delivering applications and solutions, you'd have manual build processes where you're building out your artifacts, maybe on your own laptop. You'd have manual deployment processes where you might be going out to your application server and deploying that artifact. And then you also have a lot of manual testing within there. You get the application out there and you have your QA team going in and seeing if anything's wrong. And then if you have something else, they're coming back out again and they're doing those same tests over and over again. So some of the challenges that this historical approach presents is you have lower code quality, just as not having all those tests automated. You also have more complex and error-prone releases. I'm guessing everyone here has probably been involved in some deployment where you get everything out, things are looking pretty good, and they're like, oh, we forgot to add that column or change that column length in the database. And then you had to figure out, track down the DBA and call and have all that fun. It's also time-consuming testing. So if you have new features or you're trying to do regression testing, you're getting out that team and you're doing a lot of stuff that could be automated. And then finally, this also leads to slower delivery time of new features for your client and your business users. So now I'm going to just talk about kind of three different approaches for like handling releases within DevOps. First is kind of foundational. It's called continuous integration. In this diagram, is kind of represented in this blue box. So with continuous integration, you're kind of laying the foundation for the rest of your DevOps processes. And kind of the foundation for this is that you've got your source control management system where you're tracking your source code, whether that's Java, C#, Node, Python files, or database DDL scripts. It also involves kind of having automated unit testings. So within the continuous integration, you're starting to have your source control management system. You're doing frequent commits to that system, and that's triggering these automated builds. Extending that is continuous delivery, which is kind of represented by this first line within the diagram. So within here, you still have the same continuous integration, your source control management, your unit test, but then you kind of go to the next stage where you're starting to automate the deployment into some of your lower test or staging environments, and also starting to automate some of those tests within there. So those deployments can either be done on whenever a new change is getting pushed into like your main branch, or it could be on a schedule like every night, depending on just on your team and your organization needs. And then that would kind of push it up. And if everything is passing those tests and looking good, you would then have it pause before you're ready to push that out into production. Once it's ready for production, you'd go through your standard change processes, and then you have a push button solution to get that deployed out into prod. And then the third one we're going to talk about is continuous deployment. So this extends continuous delivery, and it just kind of takes out that manual step, getting that into production. So this allows you to quickly move features all the way through. This isn't necessarily for every organization. It's going to be kind of a case-by-case scenario where you really need to weigh out your options and see if it's the right fit for you. There's also ways you can work in on kind of feature flags to get changes out in production, maybe not expose them to your user community right away, or kind of do more controlled exposure of those. That, I'm going to hand it off to MaKenzie.
Thanks, Luke. So now that we've talked about DevOps in general, we're going to talk about general foundational needs for DevOps. We will get to the database DevOps in the next few slides, I promise. So with that, our first foundational need is source control. So source control is needed to support that continuous integration portion of the CI/CD that Luke just talked about. So here we are storing source code and configurations. The icon we have here in red is Azure Git repos, but this could be Bitbucket or some other Git tool or versioning tool. So the main benefits or goals of the source control need are to have a history and a code-based approach to both code and transformations, as well as to have a location to manage the review and approval of those development changes. So pull requests into a main branch is probably what most of us are familiar with there. And then moving on to number 2 of the foundational needs, we have a build pipeline. So within a DevOps build pipeline, the goal is to generate an artifact and save that artifact to be used in the future. This is also the location within the build pipeline where we're translating that code from the source control foundational need 1 into an artifact. So the result of the build pipeline is something that is packaged up and ready for number 3 foundational need, which is a release pipeline. So within the release pipeline, we're pulling in an artifact and then publishing that artifact to an environment. What that artifact looks like and how that artifact is published will differ depending on the area of DevOps we're talking about, and we'll talk about what that looks like specifically a little bit more in the next slide. Before we hop to the next slide, just want to call out too, within the build pipeline, we have Azure DevOps build pipeline opportunity, and we'll talk about that more. And then within the release pipeline, so that third foundational need, we have Azure DevOps release pipelines that you'll see more throughout this presentation. And you'll see these 3 steps repeated throughout our presentation, just as we go back to what those foundational needs are and how they're applied to different practice areas. So with that, in the next slide, we have a little bit more information about what these foundational needs look like across different areas of the business. So in the right-hand side, you have a cycle that is showing for applications. So maybe this is source control of a web application. So this could be a Java application, a .NET application, some serverless application, etc. So the first foundational need would be in that source control in the Git repository. And then as we move through that circle into the build foundational need of applications, we have the application artifacts. So for Java, we might have jars, we might have NuGet packages for .NET applications. Maybe we have Docker images or zip and tar files for different types of serverless or microservice type applications. And then the third foundational need for applications, we're deploying that application into a specific environment. So maybe this is onto a web server, maybe it's onto Kubernetes as a microservice, maybe it's a serverless Azure function that we're deploying, etc. So that's what the 3 foundational needs could look like in the area of application development. In the middle circle, we have data integrations. So what does DevOps and what do these foundational needs look like for data integrations? So for source control, maybe we have data factory and data factory integrated with Git. And so we have those ARM templates versioned. And then as we move into foundational need 2 of a build pipeline, that is where we are taking those ARM templates and parameters and making those built into artifacts. And then thirdly, in the data integration release pipeline or release step in the center of your screen, we're deploying those data factory resources in this example or some other data integration resources. So through a release pipeline, we're taking those ARM templates and parameters that are artifacts and deploying those pipelines, link services, etc. And then lastly, on the right-hand side of your screen, probably what most people are here for is we have the DevOps across databases. So firstly, we have source control of our SQL files. So mainly this would be the DDL and a little bit less so on the actual data, more so on the structure of the data there. We'll get into what that looks like specifically in the next few slides. And then we have the build pipeline as the foundational need 2. So building a database artifact, somehow packaging up these SQL files into the artifact that needs to be deployed into the upper environments. And then for our third foundational need in Database DevOps, we have our release pipeline. So here's where we're running our DDL and our DML on a database in order to complete the promotion. So with that, we'll dig a little bit more into on the next slide, Database DevOps specifically. So before we get into the how, we'll talk a little bit about the why. So we have 3 main whys here about why Database DevOps. The first is to reduce bottlenecks and iterate faster. Second is to simplify and unify releases. And then third is to standardize release management. In the next slide, we'll talk a little bit about reducing bottlenecks. And then in the slide after that, we'll talk about those second 2 bullets. So with that, I'll jump into the next slide, Luke. So reducing bottlenecks. First question is, why do we have so many bottlenecks, specifically in database promotions or database release processes? Firstly, I think one thing that we think about is databases often have a much more complex rollback process, or maybe rollback isn't possible at all. So for this reason, maybe databases are locked down even more. There's more hesitation on making changes, so there's more review that needs to be in place if there's no rollback opportunity. So that's one type of bottleneck, maybe a personnel or knowledge bottleneck. Secondly, database changes sometimes take a lot longer than application deployments. So these changes might need to occur less frequently. They might need to occur during specific outage windows. In this visualization, that might be why all of these changes are queued up behind that database change, and that's why we have a database bottleneck. And then lastly, database changes often happen across teams if you're not in that microservices type model, or maybe even if you are, and they could have a wider impact and have wider coordination needs across the organization. So in this example, we see those changes that need to be deployed in a queue, even if we have, 5 different teams that are trying to apply changes to the same database. They at some point need to get into a line, get in order, and apply those changes. So we see database changes in general as a bottleneck, and some of these bottlenecks can be mitigated or accounted for within a database DevOps model. So just to hit this home, on the next slide, we're going to talk through a little example that was alluded to a couple times already, but we'll keep going through here. So to set the stage, we have a large release that's planned for this deployment. Maybe this is multiple applications, serverless applications, as well as Java applications. Maybe this is multiple data integration pipelines, so multiple data factory pipelines. And then if we go into so within step 1, we have this large release planned. We go through change management. This product release across multiple teams is coordinated, approved. We have a date set. We're ready to go. And if we click into the next, the deployment night begins. So we have everyone logging into the deploy. Everything is going well. Maybe we have this agile release process down really well. This is happening every so often. We have our database or our data integration changes, our application promotions as push button deploys. Everything's going off without a hitch until we get to one application that's crucial to this release that is throwing an error. And as we get deeper into that error, we see this application, if you click to the next, Luke, this application requires an index and a couple extra columns in a database table that were not accounted for throughout this process. So even something that was a well-oiled machine across multiple applications, multiple data integrations as part of a deploy, even if those are part of the DevOps ecosystem. So in that previous visual, when we had those two circles for application and data integration, even if those are going well and going off without a hitch, if we don't have that data integration or that database DevOps piece in place as well, that well-oiled machine can really come to a screeching halt as we have to go call a DBA, wait for that time-intensive index creation operation or adding a database column to happen in order for this entire release to be successful. So this really hits home the points of simplifying and unifying releases. So back in step 1, having the opportunity to make sure that those database changes are part of the original product release, as well as standardizing the release management, being a really important reason why database DevOps is necessary. So with that, we'll pivot a little bit into the how. If you could go to the next slide, Luke. So we have a little analogy here to talk about database promotions in general, and then get a little bit more into the options when it comes to database promotions. So imagine here we have a non-prod environment that is the full picture of what we want to promote up through to the upper environments. We have these 4 trees in this beautiful painting here. In prod, maybe if this is our first release to prod, it's a blank canvas. Our database does not have any tables, schemas, etc. in that. It's just the infrastructure and security pieces waiting for our deploy. If you click to the next, maybe we even have a test environment or some QA environment in between that has some partial state of what we're looking for in the upper environments. So in this case, the goal is to get that full picture or a partial picture of what is in non-prod painted onto prod so that we have the full picture of what we need when it comes to the database. So in order to do that, sticking with our analogy, going on to the next slide, we have 2 different approaches. On the left-hand side, we have a script-based approach. So in this case, the source of truth is how the database should change. So maybe we're in this painting class. We don't necessarily see what the final state of this painting should be. We have a blank canvas in front of us, and the instructor says, take some green on your brush, paint a tree on the left-hand side. Now paint another tree next to it. Okay, now take another brush, get some blue and white on it, put some clouds and sky in the sky. So it's not necessarily where we're going that we're talking about, it's what we need to do. And then conversely, we'll talk about this a little bit more in specific terms, but staying with the analogy, in the state-based approach, on the right-hand side, the source of truth is how the database should be. So in this example, maybe the painting instructor shows this painting of what your canvas should look like to the front of the class and says, okay, you can get as close as you need to this painting to see exactly how I made my brush strokes, but I'm not going to tell you how to do it. I'm just going to give you the materials and what the painting should look like, and you go with that and duplicate what I have. So those are the 2 different approaches that we have as we're talking through different database DevOps tooling. If you can go to the next slide, Luke, we have a couple more just comparisons of the 2. So on the left-hand side, the script-based approach is migration focused. So the version control, that foundational need 1, is DDL and SQL scripts that are defining the desired changes. So you'll see create scripts as well as a lot of alter scripts as you're making changes throughout the lifecycle of database DevOps. So in our original example of needing to add an index and a column to a table, you would have your original SQL scripts that you ran in the past for creating that index or for creating that table, and then you would have a create of the index and an alter to add that index and column to the table. And then on the right-hand side, the state-based approach is state-focused. So within our version control, that foundational need 1, we have the DDL and SQL scripts that are defining the desired state of the database objects. So this is more of a one-for-one if I needed to make a change to a specific table, I wouldn't be creating an alter script. I would just update the create script in my version control to say, okay, now there's another column. I would see that in the version control that difference is in place. And then the tooling is really going to make those changes for me in the database DevOps state-based approach. And then lastly, next slide, just to hit this home. In the script-based approach, the responsibility, as you can imagine as we're talking through this, is more on the developer to figure out what needs to happen. So going back to our analogy, the painter has to really know, or the instructor has to know exactly how they want the picture to be painted. I need to know exactly as a developer or whoever's making these database changes, how I want those changes to occur. Whereas in the state-based approach, on the right-hand side, the responsibility falls a bit more on the DevOps tooling to figure out what needs to happen. I come at the tooling with, here's the picture that I want to be deployed, or here's the entire create statement that looks exactly how I want it in the upper environments, and the DevOps tooling is going to find that difference and apply those changes. So with that, next slide, we'll just touch on a few different options for database tooling. And some of these toolings are more script-based, some of these are more state-based. So we have Liquibase and Flywheel, which are some big players in this space, as well as DB Maestro and Squitch. There's also tools like Apache DBUp, and then the star of the show today, Microsoft's DACPAC, which we'll talk about more moving forward. So within Microsoft's DACPAC, it is a declarative or state-based database development approach. So going back to what we just talked about previously, everything that was on the right-hand side, that full painting. It is for Microsoft SQL Server-based databases. So this includes Azure Database, Azure SQL Managed Instance, on-prem SQL Server, etc. And because it is this declarative approach, we're defining all of the SQL Server objects for a database. So we'll look at what that looks like a bit more in the next slide, but think tables, views, etc. The first step in creating this DACPAC artifact is to create a Microsoft database project. So IDEs that you can do this in include Visual Studio, or we've been really liking Azure Data Studio. That's the snippet you see at the bottom of your screen here, and you'll see that a bit more too in our demo. So that SQL Database Project extension is creating a SQL Project XML file that's defining this database project, and then we'll see the SQL files that are part of the project. If you go to the next slide, Luke, here's what is part of a Microsoft SQL Database project when we're defining the database. So in this project, we have different folders. So that's this light blue color right now for schemas, tables, functions, etc. And then a file per database object, I'll say. So we have a file in this example for the config schema, a file for the staging schema, a file to create the data warehouse schema. Then we have a file per table. So you'll see a file for creating product, staging product detail, data warehouse dimension product, etc. Same thing with a file per create statement for functions, for each stored procedure, for each view. There's even the opportunity for each like security object, if that's something you're interested in. So then once we have all of these entities defined, so that declarative state, the next slide we're talking about how do we package that up. So the DACPAC, a data tier application package is what that stands for, is taking this SQL database project. So in the middle here, those database objects are those files we just talked about. We also have the opportunity for adding in a pre-deployment script and a post-deployment script. So an example of what a pre-deployment script could be, it could be a really specific versioned release that has some more complicated data movement operations. We want to write some specific DDL to put that in a temp table for this operation so that things go a little bit quicker, and then put it back at the end. So for a post-deployment script, that could be something like seeding config type data, or any static data that's not really changing. I hesitate to say it's used for creating data. It's really used for just more config type data. There are other tools that are more beneficial for actually promoting data or data movement operations. So within a SQL database project, we have these optional pre-deployment scripts, the database objects that we talked about, and then the post-deployment scripts built into a DACPAC artifact. So zipped up all these files into a DACPAC. And when this DACPAC is deployed, the order of operations here is and we'll talk about the specific operations too, but just as we're looking here, the tooling looks at what is my target machine's current state. Then it looks at, okay, based on all my database objects that are part of my DACPAC, what are the changes that need to occur? Then it runs the pre-deployment script. It applies all of its changes that it's decided it needs to occur based on the database object. And then it runs the post-deployment script. So that's kind of order of operations and how these different pieces of the DACPAC are part of this deploy. So moving on to the next slide, what are the database project operations in the context of the 3 steps that we've talked about previously? So in the Microsoft SQL Database Project, to create this project initially, we can run an extract command to get all of those database entities into a SQL database project. You definitely have the option here to create the files manually, but why reinvent the wheel? If you take your non-prod database, if this is an existing database that you want to apply this state-based database DevOps to, you can run a SQL package extract operation that's part of that Azure Data Studio extension that we talked about previously. And then you will have all of the files that we talked about and the opportunity to version those in Git. So in this case, Azure DevOps Git. So you have a repository full of all of your create statements for schemas, tables, functions, etc. So that's the first step, is the extract piece to get into source control. Then moving on to the next step, we have the build. So the SQL package build is what is running within the build pipeline, and it's what's building a DAC package from a SQL database project. So we have all of those files that are version controlled in Git, running the build pipeline, and this build command within the build pipeline is what generates the DACPAC artifact. And then lastly, within the release pipeline, we have that DACPAC artifact that is being published to a host server. So we're running a publish command within the release pipeline with a specific target server in mind. So in this example, some prod database or some upper environment database that we're publishing to. And again, what this is doing is it's saying, what is the current state of my target environment? The tooling in this DACPAC publish command is then looking at what its desired current state is based on what I packaged up in my DACPAC. And then the required changes are applied to the database during the publish. So the next slide is just tipping this diagram kind of on its side to give a little bit more context of where Azure DevOps fits in here. So we have, as we move from left to right, the Dev SQL database, that number 1, the extract command to get into our first foundational need, which is source control, potentially in an Azure DevOps Git repository. Then moving into the build pipeline, we're running the build SQL package command to get to the DACPAC artifact that could be stored in as an Azure DevOps tool, as in Azure DevOps artifact repository, or more often just as a pipeline artifact. And then thirdly, the release pipeline, so actually publishing and applying those changes based on the DACPAC to upper environments. So to the test SQL database, or applying those changes to the prod SQL database. So with that, I will turn it over to Luke to give this in action with a little demo. We can't hear you, Luke.
Gotta love technology. Oh, you're on mute now, MaKenzie.
While he's jumping on, I don't know if you can hear me, but I can give a little bit of a background. So everything that we talked through, going from those foundational needs into the different examples of our basically three main steps: the extract in our SQL package DACPAC model to get to version control, then our build to get to our artifact within the build pipeline, and then our publish to release. He's going to walk through those three steps with a specific example. And I see he's back. Can you hear us?
Yeah, can you hear me?
Yes, I can.
Yes.
Okay, good. Glad I did the trick. All right, and is my screen back up again?
Yep.
Okay, so I don't know when I was switching off now, MaKenzie, but I'll just get it over again. So we're basically gonna pretend that we have a homegrown CRM system where we're currently tracking our leads, and we want to add a new feature so we can start tracking how our leads are interacting with our website to see what of our different practice areas they might be interested in, so we can better kind of market and try to track their business. Okay. Right. So this is just first starting off showing you Azure DevOps, and we've got a sample project set up within there. And now here we're navigating over to our Azure Data Studio, and we're showing that we've got two different databases right now. We have a non-production database where we do our development, and we've also got a production database. So I'll be showing you just the current state, how we currently have a table that is tracking our different leads, just basic contact information and stuff. And we also have a view, and we've got a stored procedure to kind of help load those leads into the database. So this is just showing you that currently the two databases are in sync and that we're able to manage those different types of entities within those. So then our first step we're going to do, we're going to go into the Git repository that we already have set up for our database project. And we're going to want to create a new branch for adding these new database scripts. So we'll go ahead and use the interface to create this branch, and we'll give it a meaningful name that we're going to add website objects. So then once we have that branch out in Azure DevOps, we're going to pull it down to our local project. And I know you can't see this. I like to do the command line Git. It's kind of comforting to me. So this will just take a minute, and then we'll navigate back into Azure Data Studio. But just checking out that branch and getting that switched over locally. So now we are on our feature branch in our database project. And what we're going to do, we're going to go ahead and create the tables that we're going to need to do to track our leads interaction with our website. So we'll go ahead and get those scripts brought over into here. So we're going to create a table that's going to track the different website pages that we have and just store some really basic information, just the name and description of those. And then we also want to create another table that's going to track the websites that the leads have visited. So we'll have the lead, the web page ID, and the time that they visited, just some basic metadata relating to that. So we've went ahead and run those in the non-prod. We can see that those tables are showing up in the non-prod database. And just to show you production, they're still not out there, obviously. Just take a minute to refresh here. Okay. So now we can see the current state with those tables added. So the next thing that we're going to do, we need to get those changes extracted from the database into our local database project. So within Azure Data Studio, they've got this update from project where you're specifying the database, that's your source, and then your target. So that's targeting the project that links up to Azure Git repos. And then this is going ahead and doing that diff to see what's different between those two. So we can see there is a change to one of our internal system account users, and then we can also see that it's detected that we've added those 2 new tables. So if we want to include all of these, we can go ahead and hit the apply button, and that's going to go ahead and create those DDL scripts locally for us. So now we're in our database view, and we can see that we've got those new tables added via the tool. And we can also see the existing scripts that we already have for the stored procedure and the view. And we also want to be able to seed some initial website data in here. So we're going to add a post-deployment script, as MaKenzie was talking about earlier. So we go ahead and do that feature here. And then from here, we can put some insert statements in for our different web pages that we have. So for this, we're putting in the different practice area web pages that we have at Zirous, our home page, we have our marketing technology, like Marketo solutions, data practice, development, integration services, and also our managed services practice area. So we're going to go ahead and get this saved. And once that's ready, we're going to go ahead and commit those scripts into our local Git repository. And again, this is small. It's basically doing a diff on the file and just reviewing to make sure I want all these included. And then we'll make a commit and put a commit message in, and then we'll get it pushed out to Azure repos. And a couple quick notes, if there's things that you don't want to include it, like sometimes you might not want to manage your database users through this, you can exclude them either within the database project, or you can also include those like in a git ignore file, so then those won't get attempted to get migrated within your pipelines. So now if we go back out into Azure DevOps, we can see that we've got our remote branch pushed out, and then we can see the different changes that we've made. We can see the scripts that were created for those 2 new tables. We can see our insert statements for our post seeding, and then we can also see where that's getting hooked into the database project. So if all those look good, we can go ahead and we can open up a new pull request to get that merged into our main line. And what we've already done for this repository, we put in some default approvers that are required to actually do that merge. So for this, we just have myself and MaKenzie, which requires one of us to approve before we let those changes get into the main line, just to make sure everything is looking good. And we've got a second set of eyes that we're not getting bad changes in there. So when she's approved that, that satisfies our restraints. So we can go ahead and complete that merge. And that'll take the changes out of that feature branch and get them into our main branch. And we've got the build pipeline set up to automatically trigger whenever new commits are getting put into that main branch. So navigating over to that section, we can see that we have a new build running right now. And within Azure DevOps, it's got a good visualization. You can drill into those jobs. You can see the different steps that it's performing, and then you can see the logs as it's happening live. So you can just kind of track the status of that build. And if there's errors down the road, you can also use this to kind of troubleshoot and get to the bottom of any potential issues you might be having.
So in this example, this is where we're running the SQL package build command, and then here we're also running another command to get that deploy report so we can see what changes would be made if we published to our particular target database. But a lot of times you just have that build project step, the one that just completed before this one, where you're building that DACPAC artifact, and that's the ending piece of your build pipeline. So that DACPAC artifact could be deployed to any of multiple other environments.
Thanks, MaKenzie. Yeah, so right now this is just kind of generating the report of what would happen if we got deployed to a certain server. So people might want to review that before actually pushing things out to a higher environment. This should wrap up in a few seconds. Okay, so now it's finishing those up, and now it's publishing those artifacts. So if we go back up to the job summary page, we can now see that we have 2 published artifacts. And then within here, we can kind of drill down and take a look at those. So we can see within here that we've got our DACPAC artifact, which we've been talking about so far today. And then this also, we have it configured to trigger a new release pipeline whenever a new artifact has been published from the corresponding build pipeline. So within here, we have some approvals in place to prevent it from going to the higher environment, in this case, production, before we have appropriate reviews, just to make sure everything's ready. So in this case, we have MaKenzie and myself both need to approve this before it can go to our prod database. So when she approves that and I approve it also, then it's going to start initiating the deployment of that DACPAC to our production environment. And then within the release pipeline, it also has a nice visual flow where you can kind of track the logs and the different tasks that are involved within that. And one thing to note as we're waiting for this to deploy out to production, within more the state-based approach, since the responsibility is more in the tool, it takes a little bit more time when you're doing those deployments because it has to do the diff between the desired state and the current state. So that can lead to some longer deployment times. When you're doing more of those script-based approaches, it's just executing those scripts one after another. So those are going to be done quicker in general. So here we can see that it's starting to do the deployment to our database.
And there are options here too within that SQL package publish that is doing the deployment of the DACPAC to have different parameters for what to do if there's potential data loss, what to do if there are entities defined that are not part of the DACPAC, etc.
Thanks, MaKenzie. So within here, it showed that we got into production. And now we're going to navigate back into Azure Data Studio and just take a look and make sure that the production database looks as expected. So we'll go ahead and we're going to do a refresh, and we can see that our new tables have been created. We also want to make sure that that post-deployment seeding scripts were run. So if we query our website pages, we can see that all those were inserted as expected. So now we're going to show you some more of the nuts and bolts of how these configurations are set up. So we'll look at the build pipeline first. Within this, it's just a YAML pipeline file where it's got different steps. So we've got our step to build the project. We also have this step that's building out the report that we were talking about earlier and showing the changes, and then also steps to say what files we want to include as our artifacts. And now if we take a look at the release pipeline, we can see that we're defining the artifacts that are going to cause this release to be created. So it's tied back into the build pipeline we're just looking at. And then we can also tell that we want to have a new release created every time an artifact is made from that. So this is just going to automatically create a release whenever we have changes that have been pushed. And then when we have those pre-approvals, that's set up within here. You have different options for kind of specifying if it can go out to a stage or not, if you want those to automatically trigger or have restrictions. And then finally, this is kind of where the heart of the deployment is at. We have this database deployment task where we're specifying how we're going to connect to the database name, and then we're also pointing it to our DACPAC file to get executed. And then finally, taking a look at our Azure Git repositories, we'll show you how we set up those approvals. So we drill into a repository, and then we can go into our policies, and we can get into our main branch here. Then you can have all kinds of different requirements for approvers that you need to have in place before people can get code into your main branch. And we've got our default reviewers, which we include down below here. And again, there's different options you can have within those. There we go. All right, so that kind of concludes the formal part of our presentation. You know, we have a few minutes left if anyone has any questions or comments they would like to share.
I had a question. How does this integrate with Entity Framework Code First, if at all?
Yeah, so when you say Entity Framework Code, can you describe that a little bit more? Give some background, exactly what you mean by that.
So with Entity Framework, it gives you the ability to actually create a database structure using C# code. And then in addition, it also handles migrations. So as you make additions, new columns with new enhancements, it also creates a, not a migration script, but migration code that actually runs against the database and updates it.
I would say it's probably kind of an alternative to some of those operations. So instead of defining in C#, the DACPAC would have these database operations defined in SQL, potentially, without knowing a ton about the entity framework there. Sorry to interrupt. Did you have something there, Luke?
No, that was good. Thanks, MaKenzie.
I have seen it's kind of an anti-pattern. If you want to do DACPAC deployments, you can use EF Core to do what's called database first development. It's kind of an anti-pattern nowadays, but you can use that to generate essentially, it's supposed to be used initially to create your first move to entity framework, but you can theoretically just keep using it, and then you create your entity framework files or your migrations. And then that can be structured as a DACPAC for repeatable deployment if you want to go down that route. It worked pretty well, but it is technically an anti-pattern. But I've seen that used before.
Okay.
Thanks, Alec.
Yeah, no problem.
And then another question, if no one else has anything at this time. So obviously, as you're migrating, you're moving the DACPAC as well as code changes. But let's say there are two features that you're moving to production, one that requires a database change and the other does not. You migrate to production and you notice that there's a problem with the enhancement that requires the database. Do you have things set up in such a way that you can back up the feature or back out the feature that involves the database change, but retain the change that does not?
Yeah, so you're talking about, okay, multiple changes. So you presumably had a couple different branches within your development, and then you're just trying to figure out how you're managing both like your application code changes and your database changes at the same time when you hit issues.
Correct.
Yeah, so I think there's probably different options related to those, and some of those, like if you need to roll back the database change or not, I mean, you could potentially keep it there, it's not impacting anything negative. You can also figure out how you're making like your application code changes relating with your database changes, that those are really tied into the same kind of release pipeline where those are going together, or if you're kind of manage those kind of in a parallel fashion. And there's obviously always options for kind of like hot fixes, and there's different rollback mechanisms too within DACPAC for some of that. Obviously, you need to make sure that you're not going to incur any data loss. So I think it probably kind of depends more specifically on your scenario and how you'd want to handle that. MaKenzie, do you have anything you want to throw in?
Yeah, in general, we found that specifically with like release pipelines, rollbacks of applications and rollbacks of the data integration components, so like Data Factory, are a lot more straightforward than rollbacks of a database. Technically, you could deploy an earlier release of a DACPAC and maybe it would work, but most of the time that's not really realistic for the cadence of database deploys. So right now, a lot of our database deploy or our release pipelines are separated out from maybe our application or data integration pieces because we're rolling back those application and data integration pieces potentially more often or rolling different cadences out there than with our database release pipelines. I don't know if that completely answers your question, Sam, but right now we don't have them tied together mainly because of that rollback philosophy. We don't really want to be rolling back database changes unless it's a hot fix type situation.
Okay, thanks.
Yeah, hi, this is Adam. Can you hear me okay?
Yeah.
So my question is, what happens in a scenario in which maybe you're adding a new column that's going to be a part of a composite key? So in theory, it's a schema change, but the data component of it is still really important, especially if you already have data that exists in that table. How is a change like that handled?
So within those deploy reports, there are different types of data movement operations or index rebuild operations, or even data loss warnings that you would see. So in that deploy report piece would be the most insight we would normally have into what is happening there. But I would say probably in that example, you're going to have a really long index creation or index rebuild, depending on how that's changing, maybe even a data movement operation, depending on where that column is getting added in. Without knowing specifics there, because in this state-based approach, we don't necessarily know the specifics, but you do get warnings on data movement, rebuilds, things like that. So I would assume you would see one or both of those in your deploy report, and that's how it would be getting deployed. But it does, I mean, if you add a column into the middle of a table, it warns you that there's a data movement operation, and it will do that. It might take longer to do that DACPAC deploy, but when you do the publish, it will do what needs to be done without data loss if possible without data loss. If you say drop a column, then there might be data loss if you let it, but it'll move the data around, shuffle it around to look like that desired target state. It'll take potentially longer. That was a little bit of a ramble there, but did that answer your question?
Yeah, I think so.
Okay.
I mean, that's a complicated change. Hopefully people aren't changing composite keys very often. But
yeah, and that's why that
using
deploy
composite keys. But
exactly.
sure.
And that's why that deploy report can be so valuable too, because if you see someone, that added something in the code that maybe from a developer's perspective looks really small. Oh, I'm just updating this index a little bit, or oh, I'm just adding a column into the middle of a table. You get to the deploy report, or you get a reviewer that has more of a DBA type mindset, and you can catch those before they actually get applied into the environments, either in that code reviewer state of the Git repository or in that promotion state of the release pipeline.